now, hey, section 1.8 limits. All right, so here's the idea. Round, go sit. All right, now, here's the idea. On our limit situation, 1.8, I want to go through the definitions. I started yesterday, but give you the formal book definitions. So here it is, goal state. I want to talk about what a definition of a limit is, kind of give you all the different graphs and show you examples of them, and go through the properties.
No.
You better run, you better take a pass.
You better run.
Can I write it? That was fast.
Oh no.
Thank you, Maddie. I also thought that joke was very funny.
From your
What, are you ever gonna get a Tesla or?
It's my duty in the corner.
All right, so now, goals here. I want to talk about the definitions and all the properties that go with the limit. We talked about what a limit is when you approach from the right and left. There's different things we have to discuss. Now, the big thing is today, when you're actually going through them and we're evaluating, can you even identify when they do not exist? That's the big idea. Can we figure that out? That's what we're going to look at. It's very simple once you see graphs of it, but we have to make sure that we know it. The big thing is learning from left and right side, because there's a difference in how they write it. Because we're not always going from both, it might just be from one direction. So that might actually have an answer compared to both sides. So keep that in mind. All right, so here's the first definition. You do not have to write all this down. I'm basically just showing you what the book has. I just took a snapshot of the book and highlighted the main things here. Okay? When they write limits, this is how it's written. We've used this notation before. It's a limit, x approaches some number, and then they put the formula behind it. The big thing is, when you evaluate a limit and you plug the c in, that should turn out to be a number. Now the idea is that we're hoping that as you plug this c in here, you can actually just get an answer. But if you can't plug in a c, maybe there's like a weird fraction, and you plug the c in the bottom number, the bottom row, and it makes a 0, then you have to learn how to simplify this thing down until you can plug it in. That was that whole differential quotient. We learned how to simplify a differential quotient until there was no h's left over. You've learned how to simplify over time. I just never told you that. Now, obviously the limit approaches when you approach from the left and right side, such that this limit will exist. That's what we're hoping for. As you approach from the right and left, they'll actually go to the same number. Now, the definition, I talked about this yesterday, it's like you're trying to see if the limit exists for every epsilon greater than 0, so that's that band, that y band, up and down. That exists because you're picking deltas, there's that weird delta symbol I was showing you, that the delta is sufficiently small enough that you're within that boundary. It's like the speed limit. You want to be as close to the speed limit as possible, up and down from it, but you want to be as close as possible.
But there's some leeway.
A little over.
There's a little bit of leeway there.
You can go a little bit higher than that.
Well, I got 2 questions.
You want me to go up?
What?
I
I
got
think
2
she's
questions.
talking
Alright,
about
I have
the
to deal with
speed limit. She's
Yeah,
talking
we
about the speed limit, Mr.
Number 1, are we getting a in-class assignment for this?
Yes.
And number 2, so you know how it says on the interstate you go 40?
Yes. That's the minimum.
Does that mean you can go 110? Or
110?
You can go 100?
No. They put a minimum because there's certain vehicles that there's certain vehicles that would peak at 40. So like what they're basically telling you is you can't take a moped on the interstate. Because a moped's peak is like 35. So you have to, like there's a minimum. Like you're in danger if you're below 40 now. So
But you could
that's
easily,
literally why they put that
You
there.
can go 100 then.
You said that
No.
there's like a
That's like the
five.
limit.
No. They're saying that there's a minimum on there where they don't want you to be any slower than that because now you're in danger. They don't want you going 110. They're saying the minimum speed, that basically it's no mopeds allowed. That's literally what they're saying.
Oh.
What about bikes?
So, motorcycles or bicycles?
No,
If you can go over 40 miles an hour, go ahead.
How do you get no like speedometer on a
You
bike?
can get a speedometer. Like, attached to
Who's
the-
that guy?
You can get a speedometer attached to your bike.
Yeah.
Yeah.
Because you can literally get a speeding ticket on a bicycle.
Yeah,
You
you
can get
can.
a speeding ticket.
Yes.
If you're
If I
going
got
too
a
fast,
speeding
Yeah.
ticket on a bicycle,
Yeah.
I'd be
Speed bikes with
proud.
leisure go 25.
That'd be
Yeah.
a story.
All right, now, okay, let's move on to the next part here. Oh, jeez, I'm way too zoomed in. All right, so next, okay, what you're seeing here, these are all the properties of limits. This is actually something you do need to know. I'll explain what I want you to write down with this. Okay, so these are the different formulas and properties for how you calculate a limit. There's a sum formula. There is a multiplication formula. There is a division formula for limits. So what I mean by that is if you had two things being added together, like the limit as x approaches 3 for, let's go 4x plus 2, right? That's my formula. You could literally separate these into two separate limits as x approaches 3 on both of them.
Wait, do you want us to write all of that down?
No, just look at the examples, that's what I'm saying. Like this is something you do need to know how to do. So that's what we're gonna go through examples today. So what you're seeing here, I have two things to agree that these are being added. So I can separate these into their own limits. This one is multiplication. It can go into its own limits if you wanted to. Now most people can calculate this without doing that, but you are always allowed to go into separate limits with all of this stuff. As you can tell, limit as x approaches 3, x approaches 3, plus limit as x approaches 3 for the number 2. All right, so you can separate into all those properties. That's using addition, multiplication, all that. And then the idea is that you can then calculate what these are. If your number in the limit is a constant, it will stay a constant. So that means this number, what's my formula? It's a constant, right? It's 2. That will just stay at 2. You don't have any x's to plug in. It's just a 2. Right?
Is that the same with
Same with 4. This is a constant. You can't do a limit and plug in 3. There's no x's to plug in. So that answer is just 4. It's a constant. It stays a constant.
Duh.
But this x, you actually have to plug in the number for x, and hopefully you can actually evaluate that. Well, this is easy. If I plug a 3 in for x, what's the answer? 3. And then you can go ahead and calculate, and your answer is 14 in the end. Now, most people can just do that, right? You look at that problem, like, I could have just plugged a 3 in the beginning. I mean, I could have, right? I went up here to this 4x plus 2. I could just plug 3 in here. There's no problem with that. You can do that. If you can evaluate a limit, that means you can plug in the number. Now, why I showed you all that? There might be a situation where you can't plug in a number. Where I can't plug in this problem, I can't plug in numbers like 0 or -2 or -3. Because the idea is that why I can't plug those numbers in here, they make negative numbers. I can't plug in 0 because it will make a -1 in there, and you can't take the square root of a negative number. So like there's limits where you can't plug in numbers. That's why they made all these rules for, can you separate problems as far as you can so that maybe you can evaluate them later. Maybe you can simplify things. Like for instance, let me give you this example. This is the best example I can give you. Let's go to 0. Let's go to 0.
So this is the shortcut for the homework.
Yeah, shortcuts. Now, here's the idea. You were doing the shortcuts already. Now, here's the idea. On this particular process, if I plugged in 0, right? Do you agree that this bottom would be a 0?
Impossible.
It's impossible. You can't divide by 0. So I can't just plug it in right away. So I have to follow all my rules that I can possibly do. I can do division rules where you can literally divide things first, or you can separate them into their own limits, because maybe that will help you out to simplify. In my case, I probably need to divide these first. I probably need to stick with the division rule. You can just divide the two. So if I divide everything by x, it turns out to be the problem I just started with. And now you can evaluate the limit. Now I can go ahead. So these are like guidelines for how you do limits, but to do them really quickly. In case you don't know what the answer is, you can separate them into their own parts. Now, obviously, some of these are like really, really basic, like simple stuff, like common sense things. You could separate them with addition. But some people don't know that. They need to see it. Now, there was something I didn't explain here. I didn't explain this first rule. You know, I explained a constant would stay constant. But if you had a number in front of some formula, you could factor it out. So like for instance, on this problem, when I separated the limit, and I was doing the limit as x approaches 0, x approaches 0 for the 2, I could actually just factor out this 4 and put it out front and just multiply it on. Now why I'm allowed to do that, now I know this is a different problem than that one, but why I'm allowed to do this on this particular problem is because I know that if I took the limit of 4, it would just be 4. So they allow you to do shortcuts where you can like simplify it really quick. Questions on how to evaluate limits. Most people know once they see it. We're going to do a couple examples of this later. Okay, now obviously we're going to be looking at graphs today. That's a majority. Like we'll get to the formula stuff tomorrow, The goal today was, can you look at a picture and interpret what the limit is, if it exists? These are great for the formulas we're gonna do tomorrow. I'm trying to break this up into 2 halves, so it makes more sense to you. Because the formula stuff is way more challenging than the drawings. All right. Ooh, I forgot to scroll down. All right, here's the other part. There is this idea of continuous functions. So let me zoom out here. All right, so what you have here is you can have functions that are continuous, like the graph is very flowing, and when you're adding them together or you're multiplying, the formulas are still continuous. If you have 2 formulas that are continuous over the entire graph and you add 2 of them together, they will stay continuous. So that's something that we're going to look at tomorrow when we start doing the functions. I'll come back to that topic. Okay, all right, questions with the basics. We'll come back to this tomorrow, I'll have them separated out. Because I cut off some of them because I was just showing you the basics. Okay, we good so far?
Yep.
We're gonna come back to that tomorrow. That'll be the next thing. All right, next thing. Let me zoom out here some more. All right, this is the last thing that they talk about. This is the big idea what we're doing today. All right, can I start out there? What's the deal with this? It's not showing my whole entire thing here. Put that down before you break it.
Oh my gosh.
Lower your weapon.
All right, now, I don't know, it's too zoomed in, I don't know what's going on here. All right, so here's the idea. What we're gonna look at today is we're gonna look at numbers, any number you want, infinities, negative infinities, we can look at actual numbers themselves, and we're gonna approach from the right and left side. So that's what we're gonna look at. And the idea is that how you can do this, you can think of it as a composite, you can separate them into their own. You can do like one at a time. It'll make more sense when you actually see it, but the idea is what we're doing is we're trying to evaluate different numbers for these things. So you're gonna get used to like the notation. If you can see the whole slide, there's other notations that are involved here. We're gonna come back to that tomorrow, because I'll make sure that those fit. All right, so here's the idea. We're gonna evaluate some limits here. So here's the example I wanna show you, and then we're gonna talk about the different answers. So, let me,
You want me to write this down?
yeah, right, draw this, like, just draw a rough sketch in your notes, so that you have something to go off of. All right.
This is what we're doing as a partner. Or is that later?
As a partner?
Of what?
It's a
whole As a class? class?
All right, so here we go. This is my problem. Okay, well, we'll do 2 of these, and then we'll start the in-class activity today. Okay, we'll do the in-class homework. We have 3 problems you have to do.
Wonderful.
All right, 3. Now, here's the idea. We have a graph. It's kind of all over the place. There's solid dots. There's open circles. And the idea of what they're going to ask you for is to evaluate the limit on a picture by just looking at it and evaluating it at certain spots. So what I mean by that, this might be one of the questions. I'm going to put this as part A. It might say, find the limit as x approaches the number 2 from the right side of f of x. And let's say this is all of f of x. This whole graph is f of x. Okay, because there might be like 3 separate functions you have. Maybe that's f of x, this is g of x, this is h of x, I don't know. Maybe they have 2 separate graphs you have to look at. We'll do one of those on the next example. Okay, so here's what we have, right? We have 2 different graphs. All right, now, we're going from 2 on the right side of 2. This is the right side of 2. How I know that? It's positive 2, but the plus sign in the back means you're going from the right side. So here's 2 on the x-axis. You have to go find, you have to go visually look, and as you go this direction from the right side, what number is it going towards? What number is that?
5.
What, negative 5.5 maybe?
Maybe.
Maybe about 5.5?
I would say
So
5 and
1, 2, 3, 4, 5.5. Yeah,
I don't really know.
let's go negative 5.5. Okay, you just have to be in the ballpark. That's the best part about limits. You just have to be close.
5.42.
There you go. Do that. Okay, does that make sense as you approach from the right?
Yep.
It had a limit. Now, let's go with the same idea, same exact idea. Now this is part B. I want the limit as x approaches negative 1 from the left side. Negative 1 from the left.
Oh, that's where it starts.
Okay, there's 2 spots, right? The graph has 2, right? You're seeing it. As I go to negative 1, here's negative 1 now. I'm going from the right and left side. This is the left side.
Yeah.
So I'm using the top half. That's coming from the left. If I came from the right, if I came from the right side of -1, I'd be using that number. So what number am I approaching on the left side of -1? I'm approaching 1. There's your answer.
One.
Genius.
That's it. They're asking for what number are you approaching when you come from the left side of -1.
This seems easy.
It is. It is.
But isn't that negative
That's
one?
you.
Not.
No. This is they're approaching from -1 on the left. This is -1 on the x-axis. I'm approaching that number. That's positive 1 up. It wants the y answer.
Got it.
Got it. Okay, good
Okay,
question.
next.
Oh, yeah,
Okay.
I keep finding one.
But the limit. So this is from the left side. You have to find this x number, right? This x number. This is -1. Approach x from the left side. Where is the answer on the y-axis? Well, my answer is 1.
Oh.
Okay. Now, if they switch this problem up, maybe they wrote this problem like this. Maybe they go, I want the limit as x approaches 3 of f of x.
1, 2, 3.
So, I'm approaching 3. Did they tell me the right or left side?
No.
I have to approach it from both.
Nice.
So, as I go to 3, this is the number 3, from the right and left side. There's 3. So 3 from the right side and from the left side. Do you notice they're going to 2 different numbers?
4 and 6.
So your answer does not exist.
The limit does not exist.
The limit does not exist. DNE.
How do you know if they're asking to
What?
right or left?
If it tells you the plus or minus sign behind the number. If it doesn't tell you anything, like on this one it says 3 and it didn't tell me a plus or minus sign behind it, you're approaching from both automatically.
Okay, so if
Yeah,
there was a
you
plus
do.
sign.
Okay. So yeah, so if there was a plus sign, let's say, now my limit does exist because I'm only going from one side of it. So if I'm going from the plus side to the right side of it,
Quattro.
that means my answer is that number. That's the right side approach.
So it's
So the answer would be 4.
4.
There's
Would
your
the
answer.
right and left be the same?
No, because on that graph, the right and left side are approaching 2 different numbers. The graph is literally going to 2 different numbers at 3.
Okay.
The left side of this, where 3 is at, the left side is approaching that number.
That would
When
still be.
you're looking at where the graph is filling.
That would still be like -6.
Okay.
You have to follow the graph.
It's gonna take me a minute.
Okay. I find that funny, you're like circling that part, of it, like the right and left side.
Yeah.
That would still be like -6.
I'm still confused.
Okay, 4.
That's the answer.
Wait, why wasn't
So,
there one?
what are we confused on? The right and left side idea?
Why wasn't there one?
Will you
that
just
was
do another one?
Oh, wait, we're doing a couple more. I'm not just trimming loose yet. What?
Why wasn't there one that was just 3?
Why wasn't there a limit when it just was 3? So, if it was just 3, right, they don't have a plus or minus sign behind it. That means I'm approaching from both,
Okay.
and they're going to 2 different numbers,
Okay.
and that means the limit doesn't exist. Because what I want to happen, when I approach from the right and left side, I want them to go to the same number.
Okay.
That's what I want. I want them to go to the same number.
So it only
So,
doesn't
like-
exist if there's
It-
2 different spots.
Exactly. It doesn't exist if they're going to 2 different numbers at the same time.
So if you had the, like-
Because at 3, there's 2 dots.
There's literally
That was
2
just-
dots. There's 2 dots where it's going towards.
So if you had like limit, as x gets closer to 0 from both the left and right.
Yeah,
it'd
so-
be -4.
Okay, so good. So let's do that one. So if we're approaching 0 from the right and left side, so they won't have the plus or minus side, they'll just say 0. So that means I gotta find 0 on the x-axis.
Got it.
So here's 0 on the x-axis. I'm gonna go find my graph. I'm gonna approach from the right and left side. What is the number I'm hitting? Negative 4. That limit existed. Because I was approaching the same number.
Because we had that side.
Because again, the number they're providing here is an x, and what they want is the y answer at that graph, if it exists. If it's giving you one answer, not 2, one answer.
Would that be the same answer if it was from the right? or
Yeah,
from-
exactly. On that particular problem, on 0, you would actually get the same number anyway, right? But when I went out to, let's say I went to -1 here, I approached from -1, the right and left side. You can definitely see the right and left side of 1 is going to 2 different answers. Like it's going here versus -2. That's 2 different answers, that would not exist then.
Okay.
And if you just want to go from one side of it, you can read off the answer. If you want to read from the other side, you can read off the answer.
How would
But,
that?
but when you approach it from one or from both sides at the same time, they better go to the same number anyway. Now, here's the thing I think people are struggling to wrap their head around. The weird thing is, okay, I think this is what most people are struggling with. The idea is like, this is your F, right? Most people are struggling with the fact like, if I plug in -1, I want a number, right? The problem is, I want one number coming out. Like on a calculator, when I type in -1 into a formula, I want it to spit out an answer. If it can't spit out an answer, one number, we have a problem. And so here's the thing you need to wrap your head around. This, what I have written right here, is different than this. They're different from each other. Here's what I mean. Let me give you an example. This is my second example today.
Why? Why is it different?
Alright, so here's my example. I'm going to try to keep this as easy as possible. I'll keep this graph pretty simple. Alright, okay, you see it's just like a parabola, right? It's a very easy thing to look at. If I said I want the limit as x approaches 0, the limit as x approaches 0, okay? Where is my answer heading when I go from the right and left side?
Oh no.
1, you'd say 1. You'd be right. Here's the weird part. If I said I wanted f of 0, not limit, just f of
Then
0,
you get the y-intercept.
you get this number, 6. Because there are two
You said
different
0.
answers. Because the limit is where the curves are approaching. This item that you're writing here is the actual valuation of the function. Like, where's the dot filled in at? If there is a filled in dot.
If there is.
Because if this dot was open and there was nothing above it or below it filled in, there's no answer. There's no solution.
DNE
It'd be a DNE.
does not exist.
Does not exist.
This word doesn't have
Have you ever seen Mean Girls?
Yes, I have.
You know when she's at the
You watched
family
it, girls'
thing
words.
and the final answer is the limit does not exist? When you said that, it made me think of Mean Girls.
Hey, what day is
It's
it?
good to do
And
that.
it's October 3rd.
All right. Okay. All right.
It's
Do
from
we
the movie.
have a better understanding of limits?
Yeah.
Okay. Here we go. Here's what you need. You need a piece of paper, separate sheet of paper.
Okay.
You need to have your name and date. It is the 3rd, October 3rd.
What day is it?
We already said that.
It's October 3rd.
I don't mean girls for all I care.
Yeah.
Can I write
What do we have to write
date?
on the paper?
What's your name?
Maybe Catty Heron.
What's the book they have? What is that?
The bird book.
Burn book. You can call it the burn book at the top.
You're going to my burn book, Mr. Worm.
There's your word's been in my
I'm
bird
gonna
book.
be out of that room.
Words.
Alright, so-
Teacher.
Alright, here we go. Alright, so here's your first problem. So there's 3 problems I'd like you to do. Now there's gonna be an A, B, C on this one.
That
So,
So there's
so
more
you're
than
gonna,
3
so
problems.
there is. So, okay,
It's not.
all I want for like on your answer is you to write problem number 1 and give me the answers for the limits for each of those problems for the same graph. So here we go. So we have A, B, C, D. So on this one, okay,
So that's
so
your
you're approaching -2 from both sides. You're approaching -2 from both sides of this graph. And I want to know the answer that you get when you approach from both sides, left and right, if it exists at all. So you're finding -2 on the x-axis, find the y answer, if you can read that, and then tell me what both answers are. Now, if you can't, just give me as close as possible, make an educated guess, because I don't have the cold grid system. Okay? Letter B here, you're approaching 0 from the right and left. Right and left at 0. Tell me what that answer would be on the limit.
I guess we're lit.
F of 2 from the right and left side, and then F of 4 from the right and left side, if it exists. So if it's going to a number, tell me the number. If it's going to 2 different numbers, it doesn't exist. It should be really quick answers. I'll give you 3 minutes.
So we're graded on this?
Oh,
Yes.
oh jeez.
Let's see where you're sitting. See
Yeah,
how
well,
long
this
it
is a class assignment.
This is a class assignment, and we're going to go over the answers here tonight.
Oh,
So
so you
it's
should.
not
You
graded.
should be fine.
It is graded though.
It is great.
That's
Also,
so
it's
much
going back to
better
my GPA.
Yes.
Mr. Ward.
Since it's a class thing.
Put me in the burn book, we'll be fine.
Can we change our answers when we like go over them?
Yes.
Oh.
What?
I'm just
What?
confused.
Should I
There's
not
not
do
a
it?
dot.
Alright,
just
Mr.
do
Ward.
it.
If you want us to hand it in.
Nothing.
We are turning it in.
Yeah, we're not done.
This is only the first problem.
That's the first problem out of 3.
Mr. Ward.
Wait, read the last line, slate.
Jacob's
Alright.
sorry.
I'm not
You got
done.
2 more minutes.
I'm not done.
You know, man, just
Mr.
show
Ward,
off.
I'm still confused because,
What was that one?
The first one you can't go for.
First one, you're going from the right and left side of -2.
yeah.
I can't tell.
The second problem, you're going from right and left side of 0. Letter C, you're doing the right and left side of 2. And then the last one, D, you're doing the right and left side of 4. Okay, try to make an educated guess. If you need to get closer, walk up there and see it. You just have to give me a number in the ballpark. That's really what I'm looking for. Because I know you're staying 20 feet away from it.
Yeah. At least.
We're sitting actually.
That's right.
It was funny.
Would you quit moving, Mr. Ford?
I mean, give us a zoom.
Dusty.
Board,
Stop
we
functioning.
could see it from back here.
I can't.
Some people are complaining.
You need
I
glasses.
always
You
complain.
know what? Take your stuff and move to the front row.
I'm comfortable where I am.
Where, Maddie, where's your actual seat? Your sitting arrangement?
Is this a negative arrow 4 or a arrow 4?
What?
A negative arrow 4 or is
That's an
that?
arrow, Luke.
That's a 4.
Oh, I couldn't see it.
You're approaching positive 4.
You just said you could see it fine from back.
But now he's in jet.
Nice.
Don't you already like it?
Oh no.
Okay, you got one more minute.
about
We should go
myself.
over these
It's
answers.
hard.
I'm
I'm guessing.
I said we just go to 2 and 3, turn around without talking about it at all.
You know, some people are not as confident in their answers.
I'm trying to get them all. That's the main thing. I'm gonna get them
It's
all.
not 8.
I hope you do.
You're getting too cocky.
Alright, and again, you gotta be in the ballpark. I know some answers will be different because you're standing a long ways away. Alright, here we go. Okay, first answer you should have. I'm approaching -2 from the right and left side. -2 is right here.
Probably.
I'm gonna go up and kind of find where it's at in the graph.
Oh, 3.
I said 4.
Oh,
Negative.
oh, 3-ish.
3.
Oh,
Oh,
3.
So I'm gonna say 3. If you said 4, I'll give it to you. It's in that ballpark.
Okay, I'm changing.
Alright, so you're within that range because I know it's kind of hard to see. I would say it's 3. Alright, so now why it's 3? As I approach from the right and left side, this is the left side, that's the right side of 2. I'm approaching that same number, that's why it exists. So my answer would be 3. Okay, now, let's go to 0. As I approach 0, this is 0, right and left side, my answer should be what?
7.
7.
7?
Yes.
I'll go with 7.
Yes.
Okay?
7.
7. Now, that is different than the evaluation at 0, but the limit is pointing towards 7. Now, 2, right and left side,
The limit does not exist.
does not exist. Because we're going to 2 different numbers.
Can I just write Negroes for my answer?
And the next one, 4, 8. 8.
Or 7.
Can we
No.
just set 7?
Eight.
That is not 7.
It's like
Not
7.
7.
How is that?
Not
Where's your
That's-
mark? Hey,
that's
you guys
it.
stick up
That's
there.
it.
What
That's
did you
it.
say?
That is A. Word. I need to show them
8.
something.
It's really hard to see from back
7.
here.
Yeah, but then it looks like it's going up
Maddie,
from.
you said you can see it fine.
I said I was comfortable.
All
I
right.
guess I can see fine.
Hey, you gotta hurry because I'm going on to the next one. Because otherwise you're gonna have to do some on your own. You
Yeah.
gotta check.
This is the Leaning Tower of
Yeah, you're
Pisa.
7.
8. 8.
It's
That is
8.
that is obviously above the other guy. Which is that?
That is
8.
It's over
You
8.
know what? Some of us struggle.
Okay, moving on. Okay, that's it. So I'm here in 6 pack.
I don't know where I'm going.
Just go. Walk away. Alright, here we go. Go.
Can you stop
Alright, so here we go. Next one.
Oh.
Okay.
Dude, what happened to
And rolling
ABC?
stats.
Oh, man.
Don't
This is
take
not-
count.
Alright, here we go. Okay, next one. Now we're starting on some of these numbers. You have to approach from the right and left side. The right and left side of this
Are we gonna
now.
get more time?
So, you got 4 minutes here.
Isn't that what we were just doing?
Right and left.
Close. These,
Will we
now you're
just
only
zoom
approaching from
out?
one side.
Please.
Just like the left.
Oh.
Or just the right. So
Wait,
they
is
can
there
go
more
to
on the
different
back
ends
of the
of the
picture or not?
What?
No.
Can we see the bottom of
There
it?
is no
Zoom out.
middle one.
There's nothing more.
There isn't? Oh, okay.
Oh, okay.
That's awkward.
We didn't
Okay.
know.
I just wanted the reassurance.
Yeah.
So we're
we
looking
need
to
a
the right of
duration.
one.
Yeah.
Yeah.
1.
So does that mean?
Why is there a dotted line?
The dashed line means, yeah, so this graph over here was horizontal, but this graph is going down and they're just showing that it was never crossing that. That's why they show a dash. It means that line right here is going down
There
kind
is
of forever
no,
that.
you're approaching 1 from the
What
left.
are you gonna do if I do?
So,
What's the
talk it over,
For the right of
you have 3 more minutes.
Doesn't work.
What's,
Oh, okay.
I'm a
So remember, those plus and minus signs means you're approaching from 2 different sides. If they don't have a plus or minus sign behind the number, that means you're approaching from both and they better be going to the same number. So when you go from one direction, it may exist or may not. Now, if you're approaching from one side, it's pointing down towards infinity. You can say it's going towards infinity or negative infinity. You can say that.
Or,
It's just, the limit technically doesn't exist if you approach from both sides, but on one side it might go to infinity.
So if it's positive, it's going right.
If this is like a plus sign,
Yeah.
you're approaching from the right side. If it's a negative, you're approaching from the left side of where that number is.
So,
Left, right,
so A is,
minus plus. That's
so A is 1 and B is doesn't.
Yeah,
We'll see.
correct.
You have 2 more
I feel
minutes.
like all my
The
answers
same
are
answer
wrong.
though.
Well, there's one.
Why didn't you just when it's
I feel like you tricked us.
Next one is gonna be like the entire alphabet, I feel like.
You're not wrong.
I feel like.
Next
they're
one's
all
tricky.
the same.
Is that half the
Alphabet,
alphabet?
I like a good
It's
chat.
gonna go to I.
Honestly, you were paying attention to what we were doing earlier. I'm gonna do one, the next one I'm gonna do the first one for you
Where's the next one?
right away, so you can see what you have.
Good job.
You're gonna do it for us?
No, I wasn't confused, now I'm confused.
Thanks, bud. Okay, you have less than a minute.
Grant, stop cheating.
I'm just confused because I got all the same answer. I don't think
I mean, it could happen. There could be some that you have the same number no matter how you approach it.
There's only 2 dots at the same number.
Which word is Stu?
There you go.
I'm kidding with yours.
Yeah, that's what I got.
Really?
Yeah. No. We're both.
Mr. Word, what's the plural form of hyperclass?
You're wrong. How do you know?
Because I know.
Do they?
I got him good.
Gosh.
My answers are locked in.
I must have zoomed. I didn't realize.
No, I was just.
That is
Wow.
put in her
Didn't realize I just thought I hit the freeze button.
$5,000.
Okay, alright. Hey, here we go. I'm gonna go through the answers really quick. Pay attention. First one, as you approach from 1 on the left side, your answer better be 1. As I go from the left side, your answer is 1. So
Sure is.
that's 1.
Got that one.
The next one, as I approach positive 1, it's going towards negative infinity.
Darn.
It's going towards negative infinity, that thing is sloping downwards.
Big now.
It does not exist, comes up later. Next one, as I approach 1 from the right and left, that doesn't exist. Because they're going to 2 different numbers.
I am.
I did that wrong.
I'm stupid.
They can approach infinity, it can go down. You're telling me it's going down
Wait.
from the right
I was
side.
looking at the dot, not the actual number.
You're telling me,
Next one, as I approach 2 from the left side, 2 from the left, it is going towards 1. As I approach 2 from the right side, it is going towards 1.
Oh, ding, ding.
The limit itself, as you approach from the right and the left, is still 1.
Yeah, it is.
It doesn't matter, it's an open circle, it's still approaching the same number, so it has a
What
limit.
happens when it's closer?
If it's closer, fine. Still the same number, it's approaching the same number.
You said open, I thought there was
It's,
a difference.
if they had an open dot
Stop
here,
attacking me.
if they had a dot here, that wouldn't make a difference. Your answer would still be 1. The only way that that problem could be different is if they asked for just this.
Then what's the dot for?
The dot is the actual evaluation for F, it's not the limit where the
Yeah,
curve's
right.
going.
Jeez.
Yeah, right.
So, alright, moving on, let's go to the last one. Now, this last problem, you have the rest of the time in class. You'll turn it in right before you leave. I will do the first one for you. Okay, I'm gonna have to zoom out, so you're gonna have to see both graphs.
Oh, both graphs?
Alright, so, you're gonna have to use both, I'll explain here in a minute.
Lord.
I'm gonna
Okay,
No.
okay, alright. So, you have 2 different graphs. One's an F graph, the other one's a G graph. And the idea is that you have to use both together to write your final answer. I will do one of these for you. I
really
will
don't wanna.
I'll do maybe this one. Okay, I'm gonna do letter A, just so you can see this. So,
I was hoping you'd do
they're all the
letter B.
same. Now, here's the
They're
idea.
not all the same.
I'm approaching approaching 1 from the left side on both of these. And what I'm gonna do is, once I have both answers, I'm gonna add them together.
Oh, that's easy.
So on the first one, letter A, I'm gonna do F with the 1 approaching from the left. Here's the F formula. I'm approaching 1 from the left. What's that answer?
3.
Okay, so 3 plus, so I'm doing that for, this
Plus
is 3.
5.
Plus, no, G, this is the G formula, and I'm approaching 1 from the left. Where's 1 at? 1 from the left. That is 5, so I'm gonna add 5, so my answer is 8.
Answer 8.
Yeah, it is.
Move on to the next problem.
There we go.
So you have to, you're learning how to do both combined and add. On your next one, it's very similar to what I just did, but now you're doing it from the right side of letter B, and on that G function, whatever this answer is for G, you're gonna have to multiply by 2 next. You have to double it before you add it. So it's getting used to doing two different graphs and kind of mixing and matching answers together. So you have to go find the answers for the limits and then plug them into the formula.
Are they all gonna be 1 again?
They were not.
First one was 8. Not 1, so no. All right, there you go. This, you're gonna turn this in before we leave, and we're not going over these answers.
Oh.
Oh, I know.
Did you get 4 for that?